There we go. Perfect.
Coming from mobile devices, we go into another very relevant topic, SIP-over-TLS, or in general, encrypted voice over IP communications. So please give a warm applause for Alexander Traut on his talk, Common Flaws in Encrypted VoIP.
Well, I love this talk because this is the first talk I can say, all of you have to take off their phone, but I can keep on my phone because that's a small challenge for you if you like. You are going to, if you like to, call me in the presentation, and I give you small hints in the presentation all around how to get into my phone. So let's see if it works out and you're hacking my phone, or at least calling my phone. You're just calling my phone. The first hint I give, it's not a telephone number. So if you see a telephone number around on some web pages of mine or something like that, no, you don't have to take that one. It's not a telephone number. So let's see if that works out. So yeah, I'm in the SIP-over-TLS. And yeah, well, you know all from web technologies, from the 90s and all that stuff in web. We had no security and no encryption and nothing, and banking was asking for, oh, whoa, somebody has to encrypt everything or something like that. And in email, we have the problem, oh, well, everyone was able to see our passwords and all that stuff. We had to digest authentication, it worked out a bit, but still content was in plain text. And well, SIP is from the same age, so we are talking about technology which is 20 years now. And SIP is the same. Everything is in clear text. It's, in contrast to web and all that stuff, it's over UDP, so it's connectionless. And has another special feature because it opens up a media stream after it was negotiated in signaling. So how do we add encryption here? You all know from web and email, that's easy. We just added TLS. That was one option. So now we had SIP, and SIP was based on UDP. So how do we add that one? And well, yeah, so we had to come up with some ideas. And the first idea is, of course, go for a virtual private network, which you put underneath everything. So you're somehow encrypting that stuff which comes over that one. Of course, that only secures our end-to-access edge. So if you are a remote worker out of your company or something like that, or if you're at your home with your speed port, with your Fritzbox, and you have the first hop, and you're just in the US or something like that, and you want to call home to your Fritzbox and go up, so you go for a private network. Another option, which came up 12 years ago or something like that, was SDES-SRTP. And the idea is quite easy, actually. It changes the UDP to TCP, and then we can do TLS above that one. So, and now we have encrypted signaling channel. And because we have encrypted signaling channel, we can exchange a symmetric key in that signaling channel. And then we have an encrypted audio channel. Yeah, but many people still liked, what about end-to-end encryption? And what about the UDP and all that stuff? So around 7 years ago, TLS SRTP, it's called, added end-to-end encryption. The problem is a bit, yeah, well, we have encryption, but what about the authentication? It's in the standard, you can go for S-MIME and all that stuff, but it's very much, yeah, we have encryption. The idea is we don't want any clear text anymore. We want to be protected against passive eavesdroppers, surveillance, whoever is watching us, Wi-Fi, just opening Wireshark, and so not man in the middle guys. but the passive listeners. So we have SRTP, and those try to get all that done with end-to-end encryption and authentication. And yeah, well, that was looked into by the University of Braunschweig 2 years ago. You can, on the YouTube channel, you can see the presentations. They did a roughly tough investigation about ZRTP. But today we are looking at SDES-SRTP mainly, and a bit in detail as SRTP, which is, yeah, but mainly SDES-SRTP. Well, of course, there were other solutions which are proprietary, and everyone came up with his own stuff. So Skype, actually Skype nowadays has a SIP interface, WhatsApp, Signal, Google Voice. Google Voice was long time their own stuff, and now they are having a SIP interface, and actually they are doing SDES-SRTP as well for attaching home phones. And that's the next point. Is anyone actually still using SDES-SRTP? That's the standard, which is 12 years old, and you have all that other options. Is that still deployed? Is that still in the phones? And yes, it is. So here we have some mobile phone apps which you can add to your phone. So that's actually the first hint in our quest. So if you forgot your laptop, you don't need a laptop to hack into my phone. You can go by your normal Android and Apple iOS phone and go for one of these apps and try to hack in my phone. So yeah, I looked mainly on iOS applications which have a port on Android as well. And then we have Android, one prominent Android app, which is a prominent stack, which is used by many phones. And I looked into the Nokia mobile phones, the former Nokia mobile phones, which were great. Everyone says, oh, they were great. And yeah, well, that's a Nokia mobile phone. They were great at their days in voice over IP and all that stuff. And what's interesting here in that situation already, we see that some manufacturers are going for several stacks or several implementations within their own brand. So actually, the Symbian S60, the Series 40 in the Azure software platform, and the MIMO stuff, all very unique. So actually, Nokia paid the money to have 4 different VoIP clients in parallel, developed in parallel. And everyone behaves a bit different when it comes to the detail. Of course, there's a standard, but in detail and in configuration, everyone was doing something different. That's interesting. And even the MIMO and MIGO stuff, which were the latest incarnation of a software platform at Nokia, even says I didn't have SRTP, at least I didn't get to manage it to configure it. And the other platforms from 2007, 2008, and 2010 all had that. So, so a different feature set, even a different feature set. Yeah, as you can see, we have only 3 implementations who have TLS SRTP, so it's not so accepted in that scope. It's more about web browsers and all that stuff. And well, finally, I looked into some Linux clients and all that stuff. What about your home router? Your router at home, your Speedport, your Fritzbox, or your internet access device you have? Well, clear text. Actually, it's everything clear text. I don't think anyone has one of these 4 at home. And these were the only 4 I found which have at least a bit of encryption and authentication. Actually, the SDES-SRTP and the TRATEC even does ZRTP. But that's it. Everyone else is using clear text. So, yeah. Well, and then I looked into this scope, in the desk phones. We have a desk phone here. We have a desk phone at the back. We have a desk phone in every closet, in the CEO place, in every invitation desk at the start. Everywhere is a VoIP phone, is a desk phone. And they're all around. And yeah, well, and then I looked into that one, and I found more and more and more implementations who have SDES-SRTP, a 12-year-old standard. And these are all devices which still get firmware updates, so I didn't look even in those who got bankrupt or something like that. And yeah, at the top you see a small link to my webpage. That's the second hint. And for the quest. And yeah, well, there you currently don't see anything yet, but it's planned to show the configuration, how to configure your phone, because most of the phones, all of the phones, default to clear text. And you have to fiddle around in configuration A, B, C, and X to get it configured for SDES-SRTP. Yeah, well, so now we have the signal channeling. It got encrypted with TLS. And yeah, well, let's double check if they do everything right. 12-year-old standard, TLS is well known. We know a lot of attacks against that one. Let's double check. And we double checked. So yeah, the first thing is the TLS Handshake. That's very much the same as in web. It is the same as in web. So your client sends a client hello, and well, the server or your callee or the other side, whoever it is, sends back his server hello, his server certificates, and so on. And in the client hello, you have the Cipher-Suites. So you are negotiating actually which standards you're taking and yeah, which encryption strengths and all that stuff. Actually, there's much, much more in the TLS client hello, many of you know. But it was enough to look on that one. So yeah, here we have the Cipher-Suites. According to the Google security team, we have the TLS ECD, Chapter 20 poly, and so on. Is a favorite one, a state of the art nowadays. It's good, but only one of the phones I looked in had it. Only one of the 42 are now. So the next one, which is state of the art, it's a R8 Cipher-Suite, you would say, and that's the one you're using all day long if you're connecting to Google services. Your browser is using that, your email client is using that, even Google Voice is now using that. So everything is around that Cipher-Suite. So yeah, well, from 42 phones, 19 used it. Okay. And we have a mandatory one, which is in the SIP standard, which was defined 2002. And that's already AES 128, so there's actually no reason to use something less or something. And yeah, well, two of the phones I had didn't use it, didn't even offer it. Why ever? It's in the standard, it's mandatory, so I didn't have it. Anyway, so yeah, well, we have a lot of other Cipher-Suites. We have triple DES, we found whatever, RC4, which is forbidden now by RFC in 2015. And as I said, all the phones are still getting firmware updates. And we have Camellia, we have Seed, we have IDEA, single DES. Yeah, single DES is a problem, of course, because it has only the bit strength. So if you can trick your phone into choosing that one, you can listen to traffic, of course. The same for the export ciphers, 40-bit, and 18 phones had still the export ciphers activated. Still today. The next one is a real problem. The anonymous Diffie-Hellman certificate suites. That's an interesting leftover from, yeah, well, it's actually a trick to not do a certificate check, so disabling authentication. So if you connect to Google, Google says, I don't care, you're saying anonymous. Yeah, well, I don't send you my certificate, it's okay. We have now an encrypted channel, so it's no authentication. Normally, everyone has that disabled, But if your man in the middle is getting somehow there and says, oh, well, I have an anonymous Cipher-Suite, connect to me. Oh, yeah, connect to me. And I don't give you my certificate. Oh, that's okay, that's okay. And he connects, because you can disable this way the certificate check. And we had 9 phones which still had the anonymous Cipher-Suites, and around 3 or 4, this worked out to disable the certificate check. And in the other 5, it didn't work out, so the connection even dropped. But why did they offer a Cipher-Suite which doesn't work when they, well, I don't get it. And yeah, well, it never ends. We had 2 phones at the start, all fixed now, God thanks, who had the null Cipher-Suite. So yeah, well, Cipher-Suites. More interesting is what happens when you play man in the middle and you want to work around that the phone actually checks your certificate is, yeah, simply go in the man in the middle and try to. Because many phones, even after activating it or something like that, they simply didn't check the certificate. So it didn't care, it didn't check it. I tested it by simply entering the local IP and the phone connected. I checked it by taking the wrong host name on the same IP, didn't check the host name and the certificate. And this attack is quite unique to voice over IP, because in voice over IP you get the server name, the actual server name at the end from DNS. So your VoIP client is doing actually a DNS NAPTER record and trying to get which services are activated on your DNS server. So you have TLS, TCP, and UDP normally. And then the admin can order the priority, which services he likes, or if he has outtakes or something like that. And in the next step, or if the phone is supporting TLS, it tries a TLS SRV DNS record, and then it gets a load balancing server if it likes to, if the admin likes to. And that could be anywhere. That domain name could be, there's no reason to go for a subdomain or something like that. It could be a different domain. And then the phone takes that domain, literally, and resolves the IP address. So if I forward as a man in the middle and forward it to a different domain, different top-level domain or different domain, whatever, and it connects to my domain and my IP address, and yeah, well, it checks my certificate. I bought my certificate for the .NET, and it connects. Whoops. No, that's not the standard. The standard is it has to take the example.com, it has to keep the example.com and compare that one at the end to the certificate. But many phones got lost on this path somehow, and they connected then, or tried to, or allowed to, the .NET, which they get from DNS. So if the man in the middle has control over the DNS for example, in a big corporate, and we have an internal intruder or something like that, and he's able to fake the DNS to his server, he can disable the certificate check. And well, from 42 phones, 42 implementations, 20 phones connected at the end. Well, that's a problem. We disable the certificate check, we have no authentication. The problem now with this one is this is not academically right, this figure, because there's no guarantee I found the switch to enable the certificate checks. Because, as I said before, these phones come out of the box without certificate authentication. I have to fiddle around with the configurations and all that stuff to get it enabled. And of course, there's always the question, Was I too stupid to enable it or to find the switch or something like that? And that's the reason I post all the configurations one day on my web page. And so if somebody is more clever than I, he can find my mistake. But actually, I contacted all of these guys, and they all admitted, at least I haven't heard anyone else, no, we made a mistake. Yeah, well, another big problem, normally you're used to see your certificate authorities or something like that, from your trust store, and you see them, you can disable them, you can accept them or something like that. That's very interesting for administrators or for getting trust into that chain of trust of certificates. And well, in these phones, still updated today, still getting firmware, and they have still outdated certificate authorities which are not trusted by your web browser anymore. But these phones still trust them. Symantec, of course, well, that's just a year ago. Statcom, that's 3 years ago or something like that. You have legacy, old bit certificates laying around from the 90s, still accepted. And the biggest problem is there are private test certificates lying all around. Who has control over them? I don't know. Yeah, well, the next problem is these phones are very much about compatibility. So they try to get everything compatible, not raising a support request or something like that. And some administrators have had problems to include all intermediates in their certificate chain, so it didn't build up the chain of certificates. And some manufacturers were clever enough to include intermediates. If you look into your trust store of your web browser, you don't see one intermediate. And well, they did. It's okay, but these intermediates don't have the lifespan which a normal certificate has, and they expire very, very easily and very fast. And there are many expired certificates even inside of the phones. And sometimes the algorithm is a bit bad, and the intermediate is matching before the CR, and then it says, oh yeah, outdated certificate. So even if you set up everything is fine, and then you have an error message in Wireshark. You don't have a error message on the phone normally, but only in Wireshark. In the phone, you only see that it doesn't work. And in Wireshark, you see, okay, it's expired. Who's expired? My certificate chain works for everyone, but expired because of these silly bugs. Yeah, the biggest problem about all that is the CAs are invisible with some devices, with many devices actually. So you don't see that you have outdated intermediates. You can't debug it, you can't look into it, you have outdated CAs, you have private certificates you don't know about, but you don't see them. They are simply in the phone. Of course, you can disassemble the firmware or something like that, but who does that? In the normal user interface, you don't see them. And because I don't see them, I'm not able to disable them or replace them. So if one of these manufacturers likes to hijack my phone, which is in every room, has a microphone, a loudspeaker, we can do everything. I can't do anything about this as administrator. Okay, interesting. Oh well. Yeah, and a lot of configuration hurdles, problems, and all that stuff, which was very surprising. Sometimes you want to add your own CA and want to say, yeah, well, I don't trust anyone, I trust only me. And then you want to add your own CA. And normally you do that by going for a web interface and uploading a certificate in base 64 or binary or something like that. And in 2 cases, I had to make a Picard Series 12, which is a private key. I have to install the private key on my phones. Yeah, well, that's not the idea of chain of trust, actually. Yeah, well, and at least we have 4 manufacturers who are Oh, well, Trust-Anchors, no, not with us. So Digium, for example, they don't have a certificate handling at all. You get an encryption, but you don't get any authentication. It's said in the documentation somehow. It was confirmed with the product manager. They don't have it. Okay. Unify, similar situation, bit different. They need a external server or something like that who configures that. We have a whole web interface where I can upload ringtones and all that stuff. I could upload a certificate easily, but no, for certificate handling and authentication, you need a extra software, extra server and all that stuff. I didn't look into that one. And sometimes we have manufacturers who deny a feature in the user interface. So I have a user interface, I have an upload button for the certificate and give some error message or something like that. No, we don't have that in the user interface. Yeah. And for some, again, the problem, is it my fault? Is it the fault of the manufacturer? Well, in one case, I still didn't get in one case, I didn't get an answer how to get validation done. Yeah. One of the other problems is firmware, phones are still updated and all that stuff. Normally you update all the libraries which are externally visible or reachable or something like that. Normally you update the TLS library as well. So yeah, but we have still outdated TLS libraries. The good news is we have TLS 1.2. So nearly everywhere except one. So I think the manufacturers are watching now via our YouTube channel. So give them an applause for 41 having at least TLS 1. Come, please. Yeah. At least one failed, but there's every time one. Well, the bigger problem is all of them at a TLS 1.2. It's quite good. Now we have 1.3, okay. But we have more than one who has still not updated their Cipher-Suites. They have still Cipher-Suites from TLS 1.0 and didn't update them, the ART and GCM stuff and all that stuff. No, just TLS 1.2, but not the new Cipher-Suites, which came with TLS 1.2. Next point is forward secrecy. So if the private key gets leaked or something like that on my server, it's harder to decrypt the connections, or it's actually impossible because every connection gets a new on key, and again, only many have still not forward secrecy. However, if the admin wants it, he can activate it, but the phone doesn't do it. The next bigger problem is certificate revocation. I found only one of these phones, from the desk phones, only one. That's 28, so only one of those. And they had a certificate revocation. So if I lose my private key and don't want to connect to that anymore, I don't have any chance to signal that to the phones. However, it's in the libraries. It must be coded, simply activated. It's all there, but it's not inside the phones. Yeah, and of course, you have, again, the wildest errors you can envision in some of these libraries. In one phone, I had the problem that SHA-256 worked. And if there was just one certificate in the chain which had SHA-384, didn't work. And I debugged it. It was really the SHA. So they only supported SHA-256, whatever. Okay, let's skip over. So that was the TLS stuff. And you see that's all very low-hanging fruit. That's outdated TLS libraries and all that stuff. I didn't go very much into that certificate checking very deeply. Often it was not activated and all that stuff. It's like a motivation start for the crowd, perhaps somebody is interested in going even deeper into that and looks even more into that. And this is, yeah. So we have done the signaling quite a bit. Now we are at the SIP level, and there the codecs are negotiated. There is negotiated where you call, whom you call, and there's a symmetry key is exchanged for the media layer, which I said before. So that's the reason why these two bubbles are highlighted here. The SIP and the SRTP layer relate. You need, for SRTP, you need a TLS connection because your symmetry key is exchanged in SIP, and SIP is normally clear text, so now it's encrypted, and now we can exchange the key. The stuff I was about previously with TLS were very much about active attackers. So if somebody gets man in the middle, somebody tries to deactivate certificate checks or something like that, that's okay, that's an active attacker. Let's have a look at a passive attacker who simply looks, watches us and reads everything, captures everything which is going in the building, from the CEO down to the closet, what talks is going on. And we have that symmetry key, which is exchanged. Normally you don't see that one because that's encrypted on the SIP level. But, well, the problem is that key really generated correctly? Is a random generator creating that key correctly and all that stuff? And that key is actually AES 1 to 8 bits. It has a salt, yeah, and it's base 64 encoded because SIP is a human-readable protocol, very much like HTTP. And I saw that one. That line, it's just that line where a key is exchanged, and that's actually SDES-SRTP. That's everything, which was added to the standard. And I saw that line, and actually here the whole project started, and I saw all the A's, A's. And I thought, that can't be a random key. That can't be a random key. And I decrypted it, and then you see in the bytes and hex, it's 31, 31, 35, 38, 30, it's only 10 bytes. It should be at least 16 bytes. And all the rest is null. So something is wrong here. And then I made it human readable, that bytes, and then it saw it, oh, well, it's just digits. 1, 1, 5, 8, and every call, it was only 10 digits. And that's the entropy, I don't have to tell you. 10 bytes, and everything is a digit, so that's 10 digits actually, and not a 1 to 8-bit RS random key. So that's a terrible entropy, and you don't need all that encryption authentication. You have just to listen to the data exchange, and then you have to know, oh, okay, that implementation, yeah, well, it has so much nulls, you can forget about it. You have just to try 10 digits, and then you have corrected. That was one implementation. Okay, one implementation can happen. And then I double-checked the other implementations which look better in base 64, but not better when I decrypted them. And again, the next one, everything was hex character, so it was not binary inside of that base 64, but it was just hex. So the character range was 0 to 9 and A to F, and not 0 to FF. And that's only 64-bit of security. A lot of did that wrong somehow, why ever. So next step, some did null bytes. Every call I did, there was a null byte flying around at the exact same position. And I had one implementation which had a null byte at every second byte. So actually, say a key was only 64-bit long because half of the key was full, and it was always the same. And well, it can be easily envisioned how that came from. They took a random generator with 1 byte, and they ditched it with in C and concatenated it, and they copied over the null byte as well. Or I don't want to see that random generator anyway, but even in base 64 stuff, I see already that something is wrong. And the next one, well, it still gives us 112-bit of security, but again, something was done wrong. As SDP or a SIP is a human-readable protocol. Human-readable protocols are use ASCII or something like that, and they did use ASCII before they did base 64. So it was they could have, yeah, well, it was always use ASCII. So the 8-bit, the high-level bit of every character is 0 as well, and that reduces the bit strength to 112-bit. Now again, here we have a scientific academic problem. Theoretically, I can make 1,000 calls, 50 calls, 20 calls, and simply have bad luck and have null bits, null bytes always at the same position. There's no mathematic proof that that's actually right. But it looks like wrong. I do 50 calls, I do 10 calls, I do 20 calls, and I get always the same pattern of null bytes or digits or something like that. So how to report that? We come later to that one. Another problem which even got a RFC already because it's a vulnerability found years ago. In the audio stream, you have the problem that you can extract the audio stream because it's flying around, but it's encrypted. But it's very tiny packets. Normally only 20 milliseconds is a packet. And you can extract out of that the vowels and all that stuff and get a feeling for what is that. And that happens if you use an audio-codec which has a variable bitrate. And 2 audio codecs do have that property, that's Speaks, and Audio-Codec, which did a lot of, which incorporated Speaks and a bit more. And this audio codec is can be used for that attack, and that's normally audio codec which is now very prominent and first tier and all that stuff. And it's flying around and it's not patched. They simply do it. They ignore the RFC, they ignore it, I don't know. So one of the tricks is of course disable it, but I'm not a big fan of disabling stuff. Another one is to go for constant bit rate or for padding bits and all that stuff. But how do you detect that one as an administrator or a user? No, as a user you can't. When it comes at the end, does the other implementation implement my Audio-Codec correctly? That's a big problem. And one of the approaches you could go for this one would be that padlock icon in the display of the remote phone, because the remote phone can actually check if one of these mitigations was done and then display the appropriate situation. But we come to that later on. Yeah, well, as we saw, disabling stuff. Security adds a lot of new stuff. I'm actually a guy, I'm not a penetration tester. I'm normally a usability guy. So I'm in usable security. And one of the first steps in usability security is, of course, the feature must be there, otherwise I can't use it. The second step is the user must use it somehow, enable it or configure it, understand it or somehow. But the third step, often forgot, is interoperability. It must work somehow with something else. And in SIP, you have the problem you are facing phones on the other side, which you have never seen before. So it must conform to the standard and all to the specification and all that stuff. And it must even work within this own world. And in this case, I went for, as testing device, I went for a Digital Asterisk. You can download it from the internet. I have a small guide on, I used the small guide which is highlighted there. And actually to use TLS and SRTP, you don't have to do much. You do just TLS enable in the config file. For my situation, I had to make a bit of, because of the floating of the audio things, I had to change to other properties, but that's it. Okay, that's cool. Out of the box, three properties to change, and then it works. That's cool. It's a bit more complicated, as you see in the guide, but that's more about the setup. When it comes to the configuration, it's really only these things. Another aspect is in RFCs develop, and SIP is mandated by many new RFCs, and one of these was added in 2005, so that's 14 years ago, and that's SIP session timers, and that's on default enabled in Asterisk. That's cool. And it's very much about when you have a longer call, about 30 minutes or so, it just double checks, is the call still up, or did somebody drop out of the call, and then it closes down the call. That's it. So it's a refresh, a ping, or something like that, how you like to call it. So on default, in Asterisk is enabled. Yeah, well, the problem is it doesn't work with SRTP, because both of these features were added at the same time back in 2010, and they weren't tested. So the first step was to fix that one, and I fixed that 3 years ago or something like that. The project is around 3 years. And the first step was to fix that both of these features work together, actually. Yes, and to get this feature really, really on, I changed it to originate. So that's a case when the Asterisk is calling the phone, so I can test that path. And I did a bit more of compact headers, just because to reduce, that's just reducing the headers a bit, because I'm on a mobile phone and I don't want to spend a lot of data. And the compact headers are in the SIP standard since 2002 in the original one, so it shouldn't hurt anyone. I enabled that one. Yeah, I shouldn't do. Well, the problem is you run into interoperability issues, which is terrible to debug. Terrible to debug, I can tell you. We have, I said about the 30 minutes. The 30 minutes are just a default value. You can change around as you like. One of the problems is there's a counter floating around for each voice packet, and that has a random number just to avoid plain text tag. So your call dropped at random times. When I started with this product, my call dropped after 2 minutes, 5 minutes, 15 minutes, 2 minutes, half hour. No, half hour not, was always 15 minutes. And at the end, I had to find out that that's related to the re-invites. And they reset somehow the counters for encryption and all that stuff. The same happened for another counter, and again, I had call drops, I had white noise, so I couldn't hear anyone on the other side anymore, or I heard, very good. So, yeah, well, and then the final thing was we had compact headers and all that stuff. Yeah. And they didn't trigger the session timers, and the other side were waiting for a ping and didn't get a ping, and so it thought, oh well, the call is dropped, so it dropped the call. So we have a lot of interoperability issues thanks to SRTP. The easiest lesson to learn from that one is, refuse. Disable the session timers. This was said in every guideline from that time, but nobody explained it. Now I know it. And the next thing is to convince the manufacturers about that it doesn't work. We will see that in the next slide. For those who are interested to play around with SDES-SRTP on a private basis, DASnet in Germany has that enabled, and so you can play around with it. That's very nice because it's always enabled. So whenever you call, every call you set up, it's at least the connection between your VoIP provider and between you is at least encrypted. You don't have end-to-end encryption, but you have endpoint to access edge encryption. What's interesting is EasyBell has a similar idea. They offer TLS, but it relies a bit on the other side. So if the other side doesn't offer SRTP, the call doesn't establish. For this, the industry introduced the SRT best offered, so it just signaled, oh yeah, I can SRTP, but I don't need to. Unfortunately, that one never ever made it into RFC. So a lot of ideas, actually three different ideas came up. You can read it in the white papers then. 3 different approaches came up for that one, and everyone is a bit incompatible. So yeah, it's complicated. If you make up a call with EasyBell, you need a very good implementation so the other side doesn't kill your encryption. Telekom Deutschland introduced that stuff last year, I think, and again they offer TLS, and the other side must support it as well. But they actually added, to get that fuss around with all that optional best effort SRTP, they added an own extension from Vodafone, MediaSec, and yeah, well, only the 2 digiboxes we had at the start implement that one. And Google Voice nowadays support it, and I don't have a Google Voice account, and yeah, well, that's at the moment it's still American and UK and US limited, so I can't say the complete details of it, only what is written on the web pages. So we have all the problems, we have all the other things, and I hate to just show problems and problems and problems. I want solutions. So never ever show problems if you don't have a approach for at least solutions. And my proposal is here. We have a padlock icon, from a web browser. And a web browser very much tries to get authenticate everything. You get wired error messages if it doesn't work and all that stuff. Okay. But in a call situation, you want to call. So you don't want to click through bad error messages or dialogues or something like that. You simply want to call. And later on, when you're on the call, you want to decide, can I talk about this topic now? Is it encrypted? Yeah, well, and we have a display. On most of the phones, we have a display, at least on the mobile phones and on the desk phones. And then you can show a padlock icon. And many of these phones actually do show a padlock icon, but only a closed padlock icon when what? We saw so many problems, so many breaks. What do they show actually with their closed padlock icon? So my proposal is here. What about an open padlock icon with the info button whenever you are, as a manufacturer, are unsure if it's really encrypted? So that would help us, for example, with the Opus, with the variable bitrate. The other party can detect, oh yeah, they didn't do padding, they still do variable bitrate. Well, we have RFC, which describes that this is attackable. It might be attackable. So let's show open padlock icon. We have Cipher-Suites, insecure, weak ones, whatever discussion you like to. It the call was built up with one of these. Yeah, well, let's show an open padlock icon, have an info button, and the administrator or the user can at least write down what was it and say, oh, you don't want to talk about this topic now on phone? I have an open padlock icon. I'm not sure. We talk about that in the next call or in private or when we meet again. That's interesting. And well, the next point is, do we really need authentication? And that's a big trend since 5 years ago or something like that, where you say encrypt everything. We don't want to have at least not clear text. Everything what's better than clear text is better. So again, that would support this situation. So you simply show open padlock icon in that case because you didn't authenticate the other party, but at least, we tried it and we encrypted it. And if there's a Wi-Fi hacker or something like that with a Wireshark, he doesn't see something on the first glance. Perhaps there's a big trick with thousands of computers to attack that one. But hey, it's encrypted, and we were true to the user and said, oh yeah, open padlock icon because I'm as a manufacturer, I'm not sure. And that's important other stuff. You don't show a closed padlock icon. Simply don't show a closed padlock icon because when you show a closed padlock icon, you are absolutely sure that you have encrypted everything. Can you be that? 2 years ago or in 2 years ahead or something like that, somebody finds a new attack vector for some new Cipher suite or something like that, and everything is broken, and your phone was not updated or something like that and still shows a closed padlock icon. No. Don't show a closed padlock icon. When you are unsure, show an open padlock icon. When you are sure, when you have done everything you know, show nothing. Because nothing should be the default encrypted authentication and all that stuff. That should be the default. And the default must not be highlighted with a special icon. So that's my proposal about that one, because, again, we had a bit of problems with that one, because some of these phones were showing a closed padlock icon, even if SIP-over-TLS was not negotiated. So even if SRTP, simply if SRTP was there. And that's a big problem, because a man in the middle simply can inject now and say, I add SRTP, and if I add SRTP as a man in the middle, the connection is actually upgraded. So the people think, I can talk in private or something like that, but actually a man in the middle just introduced a padlock icon into my call. Another case was with the DNS stuff here. Actually, again, if you control DNS, you can say, no, I don't send TLS. I only support TCP and UDP for that server. So everything connects, everything is fine. And at the end, you have a closed padlock icon. Is that correct? No. So, nobody called me, so that's a problem now. Anyway. Lessons learned from the disclosure stuff. Normal stuff we all know. Manufacturers, please. It's not a one-time project security. It's a continuous project. In one of the cases, they were arguing with me that there was no requirement to add new Cipher-Suites when they add TLS 1.2. There's no requirement to do security if you like to. For the purchasers, that's a real problem. As we saw for the data sheet, you see in the data sheet SRTP, SIP-over-TLS, and all that stuff. What does that mean? Is it authenticated? Is it not authenticated? You have to try it. We have to try it. And a please for me, to all of you when you come back to your company or something like that, please hug your administrator. Give them a big hug, because they are superwomen, superheroes. I went to the configuration of that 42 devices. I think I got crazy over that. It's so complicated to activate all that simple pieces, and they do a tremendous job to get that somehow configured, somehow run, so that you are able to call nowadays. So please give them a big hug when you're back home. That's it. Thank you.
Thank you for this interesting talk first. Are there any questions? No questions?
What clues? So I was all over your site.
Mm-hmm.
So the Spock Star Trek references, and then I'm assuming I'm using the wrong client. So I was just using a browser. Should I have been able to get to you via the browser?
The trick is my phone is connected to my Asterisk at home. Yeah, exactly, and you'd simply use my email address actually. So you use a client which allows direct SIP calling, and you simply alex@trout.de, and you go for that one, and my Asterisk forwards that sent to my client. Actually, it forwards it to my Belgium SIM card, which is now inside here, and then it goes over to. So you're reachable worldwide. I'm at least reachable worldwide via my email address. Of course, I'm attackable by spammers by that, of course, because we don't have authentication yet in SIP. We have authentication, the standards, but not in real products. But I'm actually reachable worldwide under my email address.
Right.
Yeah, that's a problem. Yeah.
Thanks for the explanation.
Yeah.
Further questions? None? All right. Thank you very much again.